All right. Alright, so here's a lesson overview on functions, and mostly we're going to be dealing with exponential functions, but before we start with the exponential functions, we're going to talk a little bit about just functions in general. So when we start out, we're going to start out by saying that for every input value, and when we say input value, we're talking about the x value, there is only one output value. Okay, so for every x, we have only one y. Alright, so when we look at this first example, we've got the order pair 2, 3, we've got the order pair 3, 5, and we've got the order pair 4, 6. What we're going to look at is we're going to look to see if any of the x values are repeating. That's not the case for the first problem. So we would say that this first example is a function. Okay, so that is going to be a function. When we look at the second example, we'll look at the order pairs 2, 3, 3, 6, and 2, 4. And we'll notice 2, 3, and 2, 4, they have the same x value. So since the x values are repeating, this would not be a function. So we're going to abbreviate that, not a function. And we would just put F and C to abbreviate function, a little shorthand. Alright, the next thing we're going to look at is the graphs. So we're going to look at some graphs to determine whether or not something is a function. And we'll see right here we're going to be looking by using the vertical line test, or some of you may have heard it called the pencil test or ruler test. Alright, so when we're doing this, we're looking at vertical lines. And every vertical line that we draw in should only pass through the graph at most one time. So when we look at those vertical lines, it's only going to pass through one time. Okay, so as we move this along, one time, one time, one time, okay, it will never pass through the graph more than once. So in this case, we would say that this is a function. Okay, if we look at the next case, alright, when we come over here and we look at the vertical line in this particular spot, you'll notice that it passes through once, twice. Okay, so since it passes through more than once, we would say that this is not a function. Okay, because it's going to fail the vertical line test, it won't pass the pencil test. On to the next step. We've got exponential functions where we have y equals a times b to the x power. And there's a couple of stipulations with that, or restraints that we have on exponential functions. The first of which, a cannot be equal to 0. Okay. The second, b has to be greater than 0, and the third, b cannot be equal to 1. So just very quickly, looking at these, we want to say identifying the a and the b. Obviously this one is not going to be that complicated. A in the first one would be 3 and b would be 4. And the second one, a would be -4 and b would be equal to 2. Alright, so those are the two examples that we have there. Those are definitely exponential functions because it satisfies those right there, those rules that we have for this. So when it says what type of functions are numbers 1 and 2, we're talking about exponential functions. Okay. We're going to start graphing some of these exponential functions. So we've got y equals 3 to the power of x. Alright, so when we have y equals 3 to the power of x, at this point we've got, what I did was I made a table. You can see the table right there. It has some values of x that I selected. Those are not any particular values. Those are just randomly selected values. And then I substituted those in, and I came up with the values for y. You can see those: 1/9, 1/3, 1, 3, and 9. And then out to the side I wrote down the ordered pairs there at the right. So if we go ahead and start graphing those, when we have -2 and 1/9, oh, need a pen. So we're going to put a point somewhere down there at the bottom, -1 and 1/3. Again, down there towards the bottom. 0, 1. Try and get that about halfway, if we can make a mark. Then we have 1, 3, and you can see it's starting to trend upward a little bit more, and then 2, 9 would be up there. So if we're just going to make a rough sketch, try and go through the majority of these points. And that's what the graph of the exponential function y equals 3 to the x power would look like. Okay, so on the next one, what we're going to do is we're going to take a similar function, and we're going to go ahead and do the table and go through the actual steps of putting in the value. We have the exponential function y equals 1/3 to the power of x. So we're going to take and put in 1/3 to the -2. And 1/3 to the -2 is going to end up being 9. So we have the order pair -2, +9. Then we do 1/3 to the -1, which would end up giving us 3. So that's the order pair -1, 3. And we're just going to do these all at once. 1/3 to the 0 power. Anything to the 0 power is 1. So we have the order pair 0, 1. Then next we would have 1/3 to the 1, which would be 1/3. So then we have the order pair 1 and 1/3. And the last one, 1/3 to the 2nd power. That would give us 1/9. So that would be the order pair 2 and 1/9. Okay. We'll go ahead and graph those. So we have the order pair -2, +9, which should be up there somewhere. We have the order pair -1, 3, it's about right. Gotta make a mark. Then we have the order pair 0, 1, down in there. 1 and 1/3, somewhere. Again, need to make a mark. And then 2 and 1/9, somewhere down in there. So we'll just go ahead and draw our curve through those. And again, hopefully you can draw a better curve than I can. But that's a rough estimate of what the graph should look like. Okay, so in looking at these, we've got, we need to make a table. We need to be careful about what we include in the values. If I didn't include something like, say, -2, your graph might look a little bit different. Might go up a little bit steeper than what it should. It might go up less steep than what it should. So just kind of be careful and make sure that you include a little bit of a range of values when you're going to graph these, and that way you can get a little bit more of an idea of what the curve should look like. So there's a lesson on graphing exponential functions.